Good afternoon. Good afternoon, everyone. In our third laboratory, we're going to try and actually focus on precision and accuracy of measurement. Again, as we did in our first lab, we're going to measure the acceleration due to gravity. Our experiment today, though, will hopefully be more precise, not necessarily more accurate. Here is the experiment. This piece of plastic with black marks on it is what we call a picket fence, of course, because it looks a little bit like a picket fence. We're gonna drop it through this detector. What this detector has is a laser, a red laser beam that goes in between here and here. This is called the photogate. Every time you break that beam of light, you are going to start a stopwatch, stop, stopwatch, start, stop, start, stop, start, stop. So you have the measurement, the precise measurement down to less than 100th of a second of when it is that those lines went through. Also, that piece of plastic picket fence has a very precise measurement down to less than 100th of a millimeter from the bottom of one stripe to another stripe. So bottom to bottom, that's exactly 5 centimeters, 0.05000 meters. Now, what we're going to do is we're going to get that photogate and connect it to a computer. On the computer, pre-programmed, it's called picket fence free fall. I will zoom in on that in a moment. And we will see what the measurements look like. It will have the position versus time, meaning right here when it just starts going through, it's gonna be 0 position, 5 centimeters, 10 centimeters, etc. Let's go ahead and do our first measurement. All I will do is to have 7 or 8 measurements and upload the files onto Canvas. So I'm going to start right here. And I need to make sure that I drop this very carefully so that it doesn't go sideways, but rather go directly downward. It's going to automatically start it once something falls. Done. Now let's look at the graph that we got, which will be the first graph that I'll upload for you guys. And let's notice what is on the graph. What you can see is the following. Try and follow the mouse right here. On the y-axis, we have the distance. As you can see, the 0.05 is where I get my first mark. Then at 0.1, 0.15, 0.2, okay, etc. Whereas on the x-axis, I have the time in seconds. As you can see, the picket fence was detected with the photogate at about 0.5 meters, which was at about 0.05 seconds. And we're at about 0.7 or so, 0.07 seconds or so is when we reach the 0.1, etc. Now we're looking for something with units of meter per second square. Therefore, I'm gonna look at a slope of overall that will get rise of a run of meter per second divided by second. Since my rise in this direction is in meters per second and the run is in seconds, then meter per second over second is gonna give me the slope. And I'm not sending you this, but I'm gonna show you the fit right here. I'm going to statistics, linear fit. And what you can see is the number that I got here is 9.811 meter per second per second. 9.811 is pretty close to the accepted value in my lab of 9.802 meter per second square, okay? By the way, it may be a tad lower than what you have in Walnut. So this is a first number, but as I said, what I'm doing instead is I'm just going to take that file and not fit anything. Your job is to fit. I'm gonna do save as, and my first save, I'm gonna basically put it somewhere here on my desktop. And we can call it 2AG experiment 3, part 1. And I'm gonna send that to you, meaning it's gonna be on Canvas. This is gonna be repeated 7 times and placed on Canvas. From then on, you're gonna be working in your lab groups on this lab according to the write-up that you will have for lab number 3.